Hello, I'm Mohan Kumar Matesh. Over the next 15 to 20 minutes, I will walk you through the Intelligent Invoice Processing Agent. It is an agentic AI pipeline for accounts payable automation that I have been building over the last month. I will cover the problem the system solves, the four agent architecture behind it, the engineering decision taken at every layer, and then I will move into the live demo where you will see the system handle a match, a mismatch, and a review case end to end. So let's start with the problem first. Every company that buys goods or service process invoices. Industry benchmark puts the cost of manual processing at around 15 to $40 per invoice with cycle time of 10 to 16 days. Around 68% of accounts payable teams still enters invoice manually, and close to 30% uh, of invoices are prone to errors. So the core problem here is the format chaos. Invoice arrives from different of vendors in hundreds of different layouts. So the traditional rule-based parser requires a template per vendor, and they break the moment a new format appears. On top of that, validation is not just about reading the numbers. I would say it is about catching the edge cases like uh, partial device or duplicate submissions or blocked vendors. Sometimes tax calculation is missed and invoices are arrived before the goods have even been delivered. So these cases have to be handled more intelligently. So traditional software solves the easy cases, and this system attempts to handle some of the harder one using vision AI for extraction and the language model for reasoning across the validation. So it's not the finished product yet, and it will be I will be specific about where it falls short. So a four agent pipeline. The system is built as a sequential pipeline of four agents. Each agent has a single responsibility, and the output of the one become the input of the next. So the first agent is reader. It accepts PDF, docs, JPEG, and PNG files. PDFs are rasterized page by page into 64 images, and it is zoomed into 2x for higher clarity, so up to 5 pages per document. The second agent is a formatter. This is where the Vision AI comes in. The formatter sends the images to the Llama 4 Scout, a Meta's latest model through the Grok API inference. The model returns a structured JSON schema with all invoice fields along with extraction notes for any field that is ambiguous. So if the output is missing critical fields or it's a fail to pass, the formatter would retries with refined prompt, like up to 3 times. If all the 3 attempts fail, then the invoice is routed to human review automatically. And the third agent is a validator. This is the brain of the system. Before making any decision, it calls 6 tools, plain Python functions, which queries the database. It fetches the purchase order and its line items, check vendor status, and check for duplicate submission, verifies the PO status, and validates the tax arithmetics, and retrieves the vendor's past validation history. So all 6 findings, along with the formatters, extraction notes, and annotations, are sent to Llama 3.1 8 billion parameter instance. This language model reason across everything and produce a decision, a match, a mismatch, or a review with confidence score and field level detail. So the fourth agent is the decision agent, which is pure Python. It maps the decision to the invoice status, writes an immutable audit log entry, and routes the record to the review queue when required. Keeping this agent deterministic was deliberate choice, and I will come back to that later. So, what makes this genuinely agentic? Many systems labeled agentic or essentially LLM call inside a for loop. So I would like to precise about what I am calling agentic here and where that autonomy stops. First, the formatter has a self-correction loop. So it observes its own output and it evaluates against the schema. And if the critical fields are missing or JSON is malformed, it acts with a refined prompt. So it's like observe, evaluate, act, and it is bounded with three atoms. Then it gives up some route to human review. So it's not open-ended autonomy. Second, the validator gathers data before deciding. So it actively calls six tools, reads their results, and reason across them. So the tools themselves are fixed set. The validator does not discover a new tool or compose them in unplanned ways. And the third, intelligence flow between the agents, not just the data. So when a formatter encounters an ambiguous value, for example, a PO number ending with a question mark, it returns the value along with the an annotation explaining why it's uncertain. So the validator reads that annotation and factors it into the reasoning. The formatter telling the validator, I was not sure about this field. So this changes the validator decision. That cross-agent annotation channel is what I think separates this from a simple function chain. And though I recognize reasonable engineering might define agents more strictly than I'm here. Real-world validation scenarios. So the system is tested against 10 real-world account, 10 real-world accounts payable scenarios. So each corresponding to the gathered generated invoice and specific expected outcomes. So we have the perfect match, an invoice within the 2% tolerance, still a match and with a warning, an invoice that exceeds the tolerance as a mismatch, a vendor name that does not match the PO, an invoice with no PO number routed to review, a quantity mismatch, an extra line item not on the PO, a low extraction confidence on deliberately garbled scan, an invoice dated after the expected delivery, or a partial delivery where only some of the PO items have been billed. Every one of these is decided by language model reasoning over rules defined in the prompt. So, not by hard-coded if-else statements. Adding a new edge case is just a prompt change, not a code deployment. So, the engineering choices. I would like to walk through four decisions explicitly because every one of them was deliberate. So the first one is Llama's force scout via Grok for vision. So invoices are visual documents. The meaning of numbers depends on which column it sits in. So and which label it sits next to it. So the text only OCR flattens that structure. A vision model reads the layout the way the human reader would. So and generalized across vendor formats without per vendor templates. My first attempt used PHI, a Microsoft's open source model called PHI 3 Mini locally through Llama, but it's hallucinated on structured extraction at 3.8 billion parameters, and also tried Gemma 4 and Google's open source model, and it also struggles with the structurization. So then I moved to the Llama 4 Scout, which addressed that problem immediately. The trade-off here is the Grok's free tier has rate limits, obviously, that would not survive the production volume. So the public endpoint is US based, which conflicts with EU data residency. So a vision model still misreads unusual layouts. These extraction nodes and confidence score reduce the impact, but they do not eliminate it. The second is the prompt-driven validation. Rather than the hard-coded rules, new edge cases are handled by updating the prompt, not by deploying the code. So all agents prompt lives in the single file, which is located in helper/prompt.py file. So isolated from the agentic logic. The trade-off is the testability here. So a small prompt change can shift the decision on edge cases that previously worked. So hard-coded rules are less flexible but deterministic and easier to audit. A production version would need a prompt evaluation harness with held-out test set. The third is provider abstraction. All LLM calls passes through a wrapper function. So swapping from Grok to, let's say, Bedrock or Azure OpenAI or Foundry is just a configuration change. This matters for SAP enterprise customers. A customer based in Germany cannot, send an invoiced data to an US-based inference provider. The trade-off is that abstraction assumes an OpenAI compatible chat completion API, which Bedrock, Azure, and Grok all expose. A fundamentally different API surface, for example, native Claude tool use would require an adapter logic, not just an environment variable here. The fourth is two-way matching with three-way ready. The demo validates the invoice against the PO. The GRN, goods receipt notes table already exists in the schema, adding three-way matching in one additional tool called in the validator and one rule in the prompt. I want to be careful. So ready is not same as the done. So the fetch GRN function and prompt rule are not implemented here, and real GRN handling has to deal with partial receipts and returns and damaged goods. So the architecture supports the addition. The production work is not revealed here. Let's jump into the system architecture. The system has 5 layers here. The front end is React application on white. The APIs is flossed with the JSON web token authentication with uh, different endpoints and stateless tokens. The agent pipeline runs in the background thread, so the HTTP response returns immediately with 202 accepted. The intelligence layer is Llama 4 and Llama 3.1 instant. So behind the provider abstraction layer, and the data layer is SQLite for the demo, and mapping to Postgres SQL is just by changing the single environment variable. The schema contains 10 tables. I would like to highlight two design choices in particular. The purchase order and PO line item table follow the same header line pattern that SAP table uses. So that choice is deliberate. It signals an awareness of how enterprise ERP system structure the procurement data, and the audit log table is append only. Every status transition is inserted. Nothing is ever updated or deleted. So this is a immutable paper trail compliance and finance audits required. And live progress is streamed to the front end through server-side sent events. As each agent completes, an event is emitted into per invoice queue, which is the front end renders live. So you will see this in the demo in a moment. So what I would do differently in production here. So before the demo, I want to be honest about few things that works for demo but would not survive in the production, I would say. So the pipeline execution model. The pipeline runs in a Python background thread inside a Flask application. So under real volume, this needs a proper queue and worker. Let's say bulk MQ with Redis, or Celery with Redis, or AWS SQS with Lambda function. So threads inside a Flask do not isolate failures or uh, uh, retry cleanly, or sometimes scaling issues. So the next thing is server sent events for status streaming. So I choose SSC over pooling for true live updates with single connection. The cost is that the browser native event source does not support the custom headers here. So what I did was I passed the JWT as a query parameter here. So that means the token appears in the server access logs. Pooling would avoid that at the cost of more requests, and a WebSocket would be the cleaner options here. So the next thing is authentication. JWTs or stateless, which scales very well, but a compromised token cannot be revoked until it expires. So a production system, I would do a short-lived token with refresh token or a revocation list. The confidence score is heuristic here, not a calibrated probability. The 0.75 bypasses the threshold, has not been validated against the real outcomes over the vendors. So the production would need track actuals against predictions and recalibrate over time. So that's the architecture. Let me show you the system running. So I have the backend running on the port 5000 and the React frontend on the port 3000. So I already logged in with the administrator account. The servant returned a signed JSON web token, which is the frontend stores and attach to every subsequent request here. So let me upload the first invoice, which is a perfect match corresponding to the purchase order of 9001. So the response comes back immediately with 202 accepted. The front end opens the SSC stream and the agent fires in the sequence. You can see the reader, formatter, validator, and the decision. Total time around 2 to 3 seconds. It's a perfect match. And the audit log shows from pending to match. Let's move to the, let me show the mismatch case for you here. So here the vendor name is mismatch for the Vivo. So the decision is mismatch with confidence score of 40 here. So the vendor name is listed in the failed fields with the exact mismatch documented. So the invoice cannot be processed to the payment without a human or override. Uh, let's jump into the third case, which is a missing purchase order number, PO number. So I'm uploading an invoice. So it's routed to the mismatch. Let me show you the document clearly. So the PO number here is uh, blank. So a rule-based system would either crash trying to look up an empty string, or worse, route this invoice to match because no PO mismatch was detected. So the reader passes the document through normally. The formatter extracts every other field correctly, vendor, line items, total, date, but for the PO number, it returns null and writes an extraction note saying that the field was present on the invoice, but it's blank. This is an annotated reasoning I mentioned earlier. So the formatter does not silently return null. It tells the next agent why. So the validator picks that up and it tries to fetch the purchase order, but with no PO it cannot. So the fetch order tool returns null instead of guessing. So the validator reads the formatter's annotation and combines it with the missing rule results and produce a review decision with confidence of 40. So the PO number listed in the missing field and the clear summary explains that the human verification is required before the payment can process. So you can see the full validator output on the validation result panel. The decision, confidence summary, and the list of failed and missing fields. So this is what finance manager needs in a single screen. Every transaction is recorded in the audit log. So bending to processing to review. With the system as the actor and the reason and the timestamp, instant only. So this is a compliance trial here. So the invoice has automatically been added to the review queue with reasons captured, and assigned reviewer can pick it up from here. So now I will act as a finance manager. And let's request we change. Requesting. So the action is posted to the approval endpoint. It writes a new row at the approvals table, role and the action with the comment and the timestamp, and it writes another row to the audit log, this time with a human as an actor, you can see here. So if I try to take another action on the same invoice now, the API will return uh, uh, 409 conflict. So the state mission enforced that the invoice is no longer an actionable state. It's tested. So though I should note that state machine is enforced at the API layer, not at the database level. So direct database write could still bypass it. So that's the full loop: an automated extraction, a language model validation, deterministic decision, human review, and append only audit trail. So the system handled an edge case that a native rule-based parser would likely mishandle, and it captured the human decision in a way that an auditor could trace later. The future roadmap, I would say. Briefly, here is what I would build next. An agent 5, a notifier. When an invoice is routed to review, the system posts a structured alert to the Microsoft Team channel through an incoming webhook or create Google Calendar reminder uh, for an uh, review. The finance team receives the work in the tools they already use. So, and the other thing is the three-way matching. The goods receipt note table already exists. So one additional tool called in the validator called to fetch GRN and one additional rule in the prompt. The system moves from two-way to three-way matching without a structural change. ERP integration. Some manual PO ingestion in endpoint becomes an event subscription to SAP Event Mesh or a data pool. So the validation logic does not change. Only the source of the PO data changes. So which is central message for the entire architecture. So business logic is decoupled from the data source. And the production providers app. The Grok is free tier works for the demo, so production would move to AWS Bedrock or Azure's OpenAI for the data assurancy and compliance, service level agreements, and enterprise support. So one environment variable, the abstraction is already in place. So that's it. That is the intelligent invoice processing agent, 4 agent, 6 tool calls, different test cases, all built over the last month. To summarize honestly, the architecture mirrors the procurement schema. The provider layer is structured for enterprise swap, and the agent patterns I implemented are, I believe, more than cosmetic. So this system is not production ready in current form, and I have tried to be specific about where the gaps are. Testing hardness for prompts, proper queues and worker for the pipeline, calibrated confidence, and actual three-way matching implementation. These all are to be the future move on this project. So you what I hope you take away with the thinking behind the choices, not just the demo. So thank you for the time. I'm happy to answer any questions you may have. Thank you so much.